Welcome back. Today we'll look at paper 12 from May-June 2023, and as always, if the video is too slow, I recommend watching at 1.5 speed, and of course, as well as watching this video, I will also recommend to check the mark scheme, just to see what additional answers they also give. Right, so question 1, a company has a LAN local area network. Give two benefits of connecting computers to a LAN. So I would say, it's going to be faster. Obviously if you just want sort of direct communication between two devices, well, that's going to be faster rather than having to go to some, external, to some external server, right? If you're playing a game, for example, of course, right, everything is going to be local. Let's just say that I would say faster. Right, since maybe two devices. Let's say two devices can communicate via a switch, or let's say two devices can communicate locally. Communicate locally, via a switch. And of course, the switch, that's just the device that all the other devices are connected to. And of course, that could be connected via, let's say, an Ethernet cable. I suppose these days, that could also be connected wirelessly. So connected locally, via a switch, or let's say, without the communication having to leave the network. So I guess, another word for this is just low latency. Having to leave the network. And then, probably here I would just put in brackets, maybe let's say, low latency, or lower latency. That's kind of what we're saying, when we're saying faster. Then for number 2, I would probably say security, because, if they're only connected to the LAN, then in theory there would actually be no way for someone to hack you, right? If you're not connected to the outside internet. I suppose, technically there are, what do they call it? I forgot what they call it, but, basically where you have, let's say, malware embedded into the hardware, and of course, that hardware, sort of shipped to the company. Now, that's not really something that a normal person has to worry about, but, one example was, Stuxnet. And I think that was where the Americans, they basically tried to blow up the Iranian nuclear facility, where basically the sort of hardware that they the hardware that the Iranians were importing in, that hardware had been sort of pre-installed with malware kind of at the factory. Obviously that's not really a sort of concern normal people have to worry with, or worry about. So you probably say that for a LAN. Let's say. Let's say if the LAN is not connected to the outside internet, then of course there's going to be good security to the outside internet. We could say security will improve, unless due to the air gap. Will improve, due to the air gap. And of course, when we say air gap, that's basically the gap between them and, let's say, the outside internet. I think for this, you can also probably mention of course, they can share files on a LAN, and things like that, Maybe they can, connect to a sort of shared server, something like that. Like file server, print server, database server, email server. Then give two characteristics of a LAN. So let's say one where it's going to be local. So we can say what is a small network. Let's say what's small, and then in bracket, of course, the local network. And we can say what for one building. Let's say in, and let's say one room, or building. Or we can say probably maybe one room or small building. Then I would say another characteristic, I would probably say they're going to be connected together via a switch, or devices would be connected via a switch. You could mention that again, users can, for example, share files over the LAN. I think maybe I'm going to say they're connected via a switch. So let's or let's say all devices will be or okay, yeah, let's say will be able to communicate, right, be able to communicate with each other. Right, okay, yeah, communicate with right, each other, and let's say via the switch. Or okay, well, all right, let's say yeah, via a central device, right, such as a switch. Yeah, no, I think, I don't know, like here, maybe saying a central device, I mean, that might be a keyword as well. Yeah, okay, the spelling. Yeah, sometimes they say central is going to be a keyword. Right, then C, one of the company's offices has one server and 4 computers connected in a star topology. Draw a diagram to show the layout of the office's star topology. So I think this question is actually a bit strange because, I mean, usually they draw this where they have a switch in the middle and then, you know, they would have the different devices coming off of that. Here they actually do it with the server in the middle, which, yeah, I think, you know, other past papers like this they haven't done. So, I mean, hopefully, like, if you drew the switch in the middle, they should also accept that. Because, to be honest, like, most, I mean, okay, well, let's do it how they do it in most past papers. So, most past papers, I guess, well, you have the switch in the middle. And, yeah, sometimes they draw these central devices as a circle. Right, of course, well, then you have, let's say, the server is connected to the switch. And, well, I mean, let's just draw the arrows. Right, of course, what then is it? 4 computers. Yeah, so of course what we say, well, computer 1. Yeah, probably I should have given myself more space. And of course, well, then you just do 4 more boxes, right? Let's say C2, yeah, C3, right, and C4. Again, so, you know, this is how they would normally do it. But I think, and yeah, let's just do this quickly. Alright, yeah, I've already got that square. Right, but I think in this, yeah, in this paper, for some reason, they actually don't have this switch, and they just have everything directly connected to the server. So, well, I'm just going to do it quickly. So let's say the S, right, then we've got what, C1, right, C2, yeah, C3, right, and C4. And of course, again, well, yeah, obviously, yeah, just all directly connected like this. And again, obviously, make sure to draw those arrows. But again, like hopefully if you did either of these diagrams, you know, they should accept both of them, I think. Okay, right, then computers can be connected via Ethernet. Describe what is meant by Ethernet. So some people get confused, you know, because I think in common terminology, well, people talk about Ethernet cables. But of course, really, an Ethernet cable, well, what people actually mean is, you know, twisted pair. So we say, well, Ethernet, right, this is the protocol. And let's just say maybe a protocol, right, or, well, I think actually it's a protocol suite. Yeah, because there's like different layers of this protocol. Right, let's say it's a protocol suite designed to allow communication between a device, well, yeah, between devices, right, over a wired connection. Whereas, of course, well, Wi-Fi, right, Wi-Fi is going to be a wireless protocol, right, Ethernet is going to be a wired protocol. Right, so, well, let's say, right, protocol suite, yeah, designed, right, let's say designed to enable, right, devices to successfully communicate. Yeah, right, okay, yeah, successfully communicate, right, let's say, yeah, over a wired network. Right, and then, I mean, we can also mention, I think what Ethernet, so data will be sent in frames. Right, yeah, okay, let's say that, right, data is sent in frames. Right, right, in frames. Right, which include a header. Right, and then the header, well, that's going to contain the source and destination MAC address. So, I mean, well, if we think about the layers, and really this is more A2 to be honest, but I mean, well, okay, let's say when data is sent over the network, right, at the top we're going to have the application layer. So I'm just going to say app. Right, then there's going to be the transport layer. So transport, well, this is, you know, TCP, right, transport control protocol. Actually, I don't know, yeah, maybe transfer or transmission control protocol. And then also a UDP, so I think like user datagram protocol. Right, well, application, that's things, let's say, for example, HTTP. Also things like FTP. I guess, I mean, let's think of email, right, like SMTP. And then, well, things like, I mean, well, POP3, IMAP, right, things like SSH. Yeah, so all these like high level application protocols. Right, then underneath that you have well TCP. And TCP, this is going to be the protocol that will ensure, let's say, reliable communication over a network. Because what TCP will do, well, this will add the packet number, right, or also called sequence number. And that will basically make sure that, well, one, all the packets arrive, because well, if packets don't arrive, okay, they're going to be resent. And two, that when packets do arrive, then they can be, rearranged into the correct order. Because, well, let's say first if you receive like packet 3, right, then you receive packet 1, then you receive packet 2. Well, of course, yeah, the receiver can then, reorder them into the correct order, right, since they've got the packet number. Right, in contrast, well, UDP, this is just going to sort of send the data in a continuous stream. And yeah, like if they receive the data, well, I guess good, right? If they don't receive the data, yeah, then it doesn't really matter. And you might think, well, why would you ever want to use UDP? But the advantage of UDP is, well, because it's just sending the data, it's not having to wait for, let's say it's not having to wait for an acknowledgement that the data was successfully received. So this is good for basically like live streaming, right? So, well, let's say videos and audio, things like, well, voice over IP. Well, I think, yeah, actually usually that's a smaller, right? So yeah, VoIP. So voice over IP, what, just internet telephone calls. Because you wouldn't want a situation where, I don't know, let's say sending to the person takes like 0.3 seconds, and then this person sending the acknowledgement back takes another 0.3 seconds. Now you wouldn't, for example, want to be having a phone call where you have a combined time of let's say like a 0.6 second delay between you saying what you're saying, then obviously yeah the person like successfully receiving it, and obviously yeah that person then responding, like. So yeah, I mean, well, because what of course what you'd have, right, is you'd have this 0.6 seconds, right, just for the acknowledgement that the sort of data has been successfully received, right, and I mean, yeah, this is not even including the person then sending anything back. Anyway, so what first we have, well, the application, right, then transport, right, then underneath that, I guess what, let's say the network layer, and I mean the network layer basically that's going to be IP, right, so IP version 4, IP version 6. And then, yeah, I guess sometimes, I mean, what they call this the data link. I mean, so the data link, I mean, well, the Ethernet layer is going to be, or yeah, the Ethernet protocol suite is going to be included in that. Right, then also physical. So physical, well, that's going to include things like Wi-Fi. I mean, I guess Ethernet is also part of the physical, right? Some of it is in the data link, some is in the physical. And yeah, I mean, physical is also going to include, let's say, the protocols for things like, optical fiber, yeah, like all these other things. But anyway, so if we think about Ethernet then, because what I was going to say was that, well, obviously the transport layer, so this is going to add the port numbers, right? And again, that's going to be the source port and destination port. And well, the port is just used to identify the particular application, right, on the computer or yeah, on the server, that the data is intended for. Because, well, let's say if you're sending data to another person, or yeah, okay, I mean, well, let's say you're sending data to another person. Now, maybe they have, their web browser open, they have a game open, they have their email client open. Well, like, how does the, network interface card and operating system, right, how do they know which application, these packets are actually intended for? And I mean, well, that's going to be done, right, based on the based on the port number. Right, then the network, well, that's going to add the IP address. I mean, hopefully we all know what IP addresses are for. Obviously used by the routers, right? The routers are going to use the lookup table. Well, I guess not the lookup table, let's say the routing table. And of course, yeah, they're then going to look up, well, let's say, well, like what the next hop is, right, to send. To send the packets onto, right, based on this IP address. So then, right, Ethernet, well, what that's going to do, that's going to add the MAC addresses. And yeah, I've probably gone on like a 5-minute detour there. But anyway, right, let's say data is sent in frames, which include, right, let's say the MAC address. And actually, right, let's not say the MAC address, let's say the source and destination MAC address. Because again, there's going to be two. No, I think I should have said header, right? So yeah, which include, let's say, right, a header. Or let's say, yeah, which contains. Right, so yeah, there's going to be a header which contains the source and destination MAC address. Alright, and let's say, yeah, and trailer. So I think the trailer actually has a sort of like error checking. Yeah, I can't remember if it's a checksum. I mean, I think if we just say, I mean, if we say checksum or sort of, you know, error checking bits, right, that should be fine. Right, yeah, which, let's say which contains, I mean, I'm going to put both actually, right, let's say checksum, right, slash error checking bits. I think, and they also call it, I guess you can call it the delimiter. Yeah, right, let's say and a, I think actually maybe it's called frame delimiter. So what a frame delimiter is going to be, well, that's just going to be a sequence of bytes kind of indicating, well, like this is the end of this frame. Because otherwise, you know, if you think, well, if you just got a continuous stream of ones and zeros, like how does the receiver know, like when this is the start of this frame and the end of the next? Yeah, okay, like when does it know, well, when is it the end of this frame and the start of the next frame? And of course, what it can do that, right, based on a delimiter. Same if we think about files. Now, let's say we have a file, I don't know, we've got sort of like, or if we just do name, or let's say, I don't know, yeah, like John, I don't know, John Smith, right, something simple. Well, of course, in this case, right, the delimiter is the comma, right, therefore that's how we distinguish, of course, right, this is the first name, this is the surname, right, based on this delimiter. And of course, right, it's going to be the same thing for Ethernet. I think that's fine, and then you can also mention CSMA CD, right, so CSMA CD, right, so our carrier sense multiple access with collision detection. Right, is also, I guess, implemented or included. I mean, what to, let's say, right, to handle collisions. And I guess, I mean, really just on bus networks, right, let's say, yeah, on bus networks. Because, I mean, well, if we're using a star network, then, yeah, we're not going to have collisions. Okay, yeah, so I think that's fine. Right, then the network runs a thick client model. Describe what is meant by a thick client. So, well, thick client, of course, well, this means, right, big. So, I mean, well, you know, sort of big, powerful. So, of course, here we're saying what the client is going to be the one doing the processing. And the server, I mean, sometimes they say, right, the server does no processing. I think in this particular mark scheme, they say, well, the server does, you know, sort of little or, yeah, sort of not much. Because, like, I think in reality, well, to say the server does, like, zero processing, or, you know, alternatively, let's say in a thin client, right, to say that in a thin client, the client does zero processing, I mean, yeah, I think that's probably a bit extreme. You know, in reality, it's more going to be, let's say, what, like 1090, right, or, you know, equivalently, let's say 9010. And in this case, we're saying what the client is doing, let's say, you know, like the majority of the processing, right, the server is just doing a little bit of the processing. So yeah, let's explain that then, right, and we can probably also say that the software and files are also stored locally. Yeah, so let's say that. Maybe let's say most, because again, I mean, this is not necessarily like 100%. Right, most of the software, right, data, and what we can say, yeah, is installed, right, slash stored locally. Right, yeah, let's say locally, right, on the client device, or yeah, on the client. And what, let's say, yeah, the client will do the majority of the processing. Okay, well, let's say, right, let's say, yeah, do all. Right, let's say, well, all slash maybe majority, or yeah, the majority of. Because actually, well, one exam they said, right, you had to say all. Yeah, this exam, I guess they say, well, sort of most. So that's what I'm going to say, like all slash majority, right? I mean, hopefully, yeah, to give both answers. Right, the client will do, yeah, all slash majority, right, of, yeah, the processing. And what we can just say, what, taking load off the server, which, you know, doesn't have to do much in comparison, basically. Yeah, all right, and taking load, right, off the server. Right, let's say, yeah, which, right, and well, let's say, right, does no, right, slash limited processing. Well, I'm going to say, right, limited, yeah, processing, right, in comparison. Because, I mean, the thing is, like, even responding to the query, I mean, that's going to be some processing, right? Like, if the client is sending a request, like, even if the even if the server is literally just sending, you know, like, OK back, right, just, you know, a simple sort of, like, 1 or 2 byte acknowledgement, of course, you know, that's still processing, right, to actually, yeah, take in this input. yeah, obviously, you know, form the response, right, and then send it in the correct format. Anyway, right, the next one then, a horse riding school uses a database lessons to store data about lesson bookings. The database is created and managed using the database management system, DBMS. The table contains names and descriptions of DBMS features and tools. Right, complete the table by writing down the missing names and descriptions. Okay, so this was the same as paper 11 yesterday, right, data dictionary. And here I do actually have a picture of this. So if you saw the video I made yesterday, and hang on, let's just select the pen. So, I mean, well, this here then, this is just the data dictionary for a particular database. Right, it's called the Chinook database. And this is just going to be a database while containing data about music. So here where you can see we've got the album, right, we've got artist, and I mean this is a good test database, right? Because yeah, they have about, I think maybe 10 or 11 different 10 or 11 different tables or relations. And of course, yeah, then you can, you know, practice doing different queries, right? Practice joining them, yeah, things like that. Right, anyway then, so what we see here, right, the data dictionary, one is going to include what all of the different relations, so we see album and artist. Then it's going to include what the different columns for each relation. So of course we see album ID, and it's saying, right, that's the primary key. Obviously, we can see the data type, right, that's an integer. And I think when it says 11, I think that's maybe saying what it can be 11 digits. Right, of course, yeah, then we've got varchar, right, we've got another int 11. Right, then it's also got the indexes. So the indexes, well, one is the primary key. And again, well, this is a B tree, right, which is kind of like a binary tree. Right, this one is unique, right, so all the values have to be unique. And if we try to insert a value that's not unique, well, then let's say the database, right, well, in this case, right, MySQL, the DBMS, is going to give us an error saying, you know, obviously kind of like insert or update error. Yeah, obviously, I don't know, say the value you're trying to insert is not unique, right? So that's going to be good for maintaining data integrity. And then obviously, well, the cardinality, right, that's just the number of, let's say the number of unique values, effectively. Right, then when it says FK, I mean, I think that's just going to be the foreign key. And then of course, well, we can see artist, right, just has the same details, yeah, for each of the different relations. So I mean, what we can say, I mean, a good word to use is going to be metadata. So let's say, right, contains metadata. And what metadata means is, well, I mean, basically meta, right, so it's sort of data about data. Because if we think, well, I mean, like this is literally data about the tables, right, or yeah, data about the relations, in terms of, well, you know, what are the columns, what are the primary keys, what are the foreign keys, yeah, what are the data types, yeah, obviously, etc. Right, let's say about, I don't know, we'll say what each relation, and let's put in brackets, let's say, right, columns, well, I guess, right, let's say column names, right, and their data types. Let's say, I don't know what indexes, or we can say primary keys. Yeah, primary keys, right, foreign keys. Yeah, okay, right, keys, and yeah, let's say indexes. And if people don't know what an index is, well, an index, like we saw, is going to be a B tree. So, I mean, basically it's like a binary tree, right, a bit more complex. Now, binary trees are actually sort of an A2 topic, right, although some people might be familiar with them. But anyway, so a binary tree, well, it's just going to allow, I guess we say what it's going to allow fast searching, right? So if we do, well, okay, I mean, if we're searching, you know, based on a column, right, that has based on a column that has an index. Now, if the column doesn't have an index, right, then of course, well, we're not going to get that speed improvement. So yeah, it's going to allow things like, well, say order by, right, it's going to be fast. Things like group by, okay, that's also fast. Yeah, if we're doing a where condition where we want to find like all of the elements that have a value, you know, greater than a certain value, right, things like this are all going to be fast, yeah, if we're using an index. Right, the next one, query processor. So we can just say, I mean, it's kind of like what part of the code. Yeah, I mean, I don't know. Let's say like maybe a feature. Right, then what this is going to be? Well, this is going to be the thing where, of course, like they type in their, they type in their query, right? They type in their SQL statement, right? The query processor is then going to parse it. And I mean, when we say parse, that just means, well, let's say if they type in something, I don't know, like select, let's say, right, select, right, something, yeah, from, you know, some other table, right, then they have like a where condition. Well, the parser is just going to break that down. For example, it's going to check what is the syntax valid, right? So first it's going to look, it's going to see, right, this token select, right? Then it's going to break down, all of the things we're selecting, right? Then it's going to see, well, right, there, of course there should be from, right? Then of course it can see, well, right, then there should be a table name. Obviously then I don't know, you can have like a where statement or where condition, right? It's gonna pass that, right? Try to understand what it's doing. So let's say that, right, a feature which will right, let's say parse, right? So parse user queries. And I guess in here, well, let's say like SQL code, right? So I mean that's what their query is. Right, let's say it will parse their queries, right? Execute it. And I guess we can say, well, and display the results. I guess we'll display the results. Right, slash, update disk contents. Right, let's say update disk contents accordingly. And I mean, well, when I say update disk contents, this means like if they do an update statement, then of course, well, obviously the sort of like, let's say the valid data on the disk, right, should also be therefore updated. Likewise, if they do an insert or delete, of course, right, the actual physical hard drive or the SSD, obviously, that data has to be updated. Right, the next one, a model of a database that is not specific to one DBMS. So this one, it's just one, either you remember or you don't. It's going to be logical schema. Logical schema, well, that's going to include things like, say, let's say an entity relationship diagram, right, where, I mean, if people have forgot, that's where you have the different entities. And then, for example, you say, well, this is, I don't know, maybe like one-to-many. Maybe this one is sort of, I guess like one-to-many again, right? This is one-to-one. So I think people remember these, hopefully. Right, schema, that's an A. And of course we see, well, this is independent of, any particular DBMS, right? Because, I mean, well, we can use, right, this for, let's say, MySQL, but we could also use it for something, I don't know, something, let's say, like MongoDB, something like Solar, Elasticsearch, right, various different databases. Right, then a software tool that allows the user to create items such as tables, forms, and reports. Now, to be honest, this one I wasn't 100% sure about. Like, I would have probably just said something like user interface, but I think here they actually call it developer interface. And like if, I mean, I guess one example, one you can look at, where it's called MySQL Workbench. This is software you can use basically to sort of, let's say, make managing the database easier. This will let you kind of like visualize the data in tables. It will let you sort of, go into the table, like you sort of manually insert data, delete data, like almost kind of like Excel, to an extent. Although of course you can also, run your queries here as well. Like other good ones, well, PHP MyAdmin, right, which you can also get if you install XAMPP. And actually, I've got a video showing how to install XAMPP, right, if people want to actually download MySQL and obviously run the SQL statements themselves. And of course, say like loading in a database, for example, like this Chinook one, right, which people can easily find if they search online, right? Just try type in, like Chinook SQL download, and you can easily find this file. Right, then we want to explain why referential integrity is important in database. So referential integrity, this is about, I guess maybe three things, or two things maybe. We want to ensure that the data is, I suppose correct. Like one thing we say, integrity is about, I guess ensuring it's correct, right, up to date and not being corrupted. If we're talking specifically about referential integrity, well, if we think reference, right, this is talking about a foreign key referencing a primary key. So we wouldn't want a situation, let's imagine we have, maybe some courses table. And let's say that, in this courses table, or this can be like course teacher or something, like we might have a situation where, let's say we have, teacher 1, and they teach, the course ID 1. But let's say, like we might have had a situation where, let's say, teacher 1 has now left, and instead, well, now we've only got like teacher 2, teacher 3, teacher 4. So like what we've got is kind of invalid, right? Because, well, we've got a course taught by teacher 1, but of course, teacher 1 doesn't now exist, right, in the teacher table. So this is what referential integrity is about. It's about ensuring that for every foreign key, right, there's going to be a corresponding primary key. And I think they actually call this like orphaned, right? So there's going to be no orphaned foreign keys. And I mean, yeah, if you think about an orphan, right? I mean, obviously that sort of makes sense, right? Where that sort of definitional word is coming from. So let's try and say that, right? Referential integrity, and I mean, first let's give a sort of general definition. Right, I guess what maybe is about maintaining consistency. Right, maintaining consistency. Yeah, and I guess what sort of up to date. I mean the grammar here is not really that good. I mean, if you want to say like up to dateness, although yeah, I think that's probably not really a word. Right, but anyway, consistency and up to dateness, right, of data. Right, in the relations. Alright, and then I think now let's be more specific. So let's say, right, in particular. Right, yeah, kind of right, in particular. Right, it's about, or maybe let's say, right, it's used to ensure. And let's say what I said, so, right, ensure that each foreign key. Right, yeah, each foreign key, maybe in every relation, right, has a corresponding primary key. Yeah, and I mean here we can just go IE, right? So IE, right, no orphaned nodes. And obviously, yeah, you can explain that if you want, or well, no orphaned. I guess you can say what, tuples, or yeah, no orphaned rows. Yeah, and then so you could add. Okay, so let's say for example we can add a rule, and the way to do that, I think you use it as well, so I don't know, like on, and then it's like cascade or something, or yeah, maybe like on cascade delete. And what this means is, let's say for example, I don't know, maybe we have another one right here, like teacher, right, teacher 3, and they teach course 4. So what this would mean if we have, on cascade delete, then let's say when teacher 3 is, sort of deleted from this teacher's database, or yeah, this teacher's relation, right, then automatically any foreign key that references this, teacher 3, right, is also going to be deleted. So of course that means, right, I mean, yeah, this course would also get deleted. And I mean the video, well, okay, right, let's say the example I used in the other video is, let's say you have a website, right, each user can make a comment. Now when that user gets deleted, or yeah, when the user, deletes their own account, right, then of course, like maybe we would want to automatically delete all of their comments, right, otherwise we're going to have comments that exist for a user that doesn't exist. So yeah, I mean, let's say maybe, right, a cascade, and I'm going to put this in brackets, right, since, okay, not brackets, right, capital letters. Well, I'm going to put this in capital letters since it is an SQL keyword. Right, let's say a cascade, right, keyword or statement could, okay, let's say rule, right, rule could be used, right, to automatically, right, let's say, yeah, automatically, I mean, well, let's say, right, delete any records with a foreign key. Yeah, okay, or let's say that. Right, yeah, automatically delete, right, any records, right, with a foreign key that references a deleted primary key. Yeah, I mean, hopefully that makes sense, right? With a foreign key, right, that references, right, references, yeah, any deleted primary key. Okay, right, then the database lessons has the following tables, right, horse, which has, well, horse ID, right, name, height, age, horse level. Right, then student has, well, student ID primary key, then first name, last name, rider level, and preferred horse ID. So I guess, well, this preferred horse ID, right, of course, this is going to be a foreign key, yeah, to the horse ID, right, in the horse table. Right, then lesson, well, that has lesson ID, right, date, time, student ID, right, of course, well, yeah, it's foreign key, right, horse ID, foreign key. Right, then the lesson content. Okay, dates in this database are stored in the form, what, hash, and then, well, obviously, yeah, date, right, month, year. Right, the fields rider level and horse level can only have the values beginner, intermediate, or advanced. Describe 2 methods of validating the field rider level. So, I mean, for this, it's kind of a strange question because, like, I mean, the way you'd actually do it with, well, I mean, yeah, okay, let's say the way you do it in SQL, or sort of MySQL in particular, I mean, you'd use something called triggers. And well, in fact, actually, to be honest, like, rather than that, you'd actually probably use something called an enum. Now, an enum is actually an A2 thing, but an enum is going to be basically a set of allowed values, right? Or you can say it's a whitelist of allowed values. And any value that, you know, isn't in this set or isn't in this whitelist, right, it's just going to be automatically kind of, you know, rejected. So I mean, yeah, like enums would be the best. And the good thing with enums as well is that, well, obviously, yeah, one, it's going to ensure that, you know, you've entered the valid data, but you can also, I mean, since, well, right, they're numeric, we would say, for example, let's say beginner would have the value 1, right, intermediate would have the value 2, advanced would have the value 3. Therefore, you could check, let's say, for example, a rider needs to be like maybe intermediate or advanced, I don't know, to enter a certain competition, right? Then you could do something where you could check, well, like, let's say, right, is rider level, or let's say greater than or equal to 2. Because, of course, I mean, here, like, well, I mean, they're literally sort of a numeric thing. But, I mean, even though it's numeric, okay, it's going to be using a text label, right, just to make it easier for sort of humans to understand. Right, I mean, there's also something called triggers, which I also sort of, well, use ChatGPT to generate an example of. So, I mean, you can just see the syntax here. I mean, obviously this is not required for A-level, right? But just, yeah, just if people are curious, where you're going to create this thing called a trigger, and then what I was going to say, right, before each insert. So, right, as you try to insert something, right, before MySQL actually, you know, sort of fully performs the insert, where it's just going to do this code. And I guess here it's saying, well, right, if the sort of value that we're trying to insert, right, is not in this list, well, then it's just going to, you know, set this error message, yeah, like invalid skill level. So, like, I think honestly, like, you should be able to say that, like, you know, probably both of these, right, enums or triggers, because they do say in the mark scheme, if you have an answer that goes beyond the syllabus, right, they should accept it. But yeah, I mean, here they probably just want a simpler answer. So I think you can probably say, what, you want to check that it's a string, or yeah, check it's alphanumeric. Yeah, all right, well, okay, let's say a type check. Right, type check, let's say, right, ensure, yeah, right, ensure data, right, is alphanumeric. I mean, or we could just say alphabetic, really. And well, let's say, right, a string. Right, yeah, and reject any that isn't. You know, but, like, to be honest, I mean, why this is strange is because, well, obviously, if you were actually programming this in real life, I mean, you could just use an if statement. So you go, well, like, yeah, if data equals beginner, right, or data, you know, or data equals intermediate, right, or data equals advanced, right, then, you know, insert the data, right, else, yeah, output error message. And, like, I mean, in that case, well, it's just a simple if statement. I mean, you don't need to do a type check. Likewise, I mean, you don't have to do a length check because you're literally checking, right? I mean, does the input data equal beginner, right, or does it equal intermediate or advanced? Yeah, but I think, yeah, honestly, like here, I mean, they say length check, even though, like, in real life, you'd actually never do this. Right, and then, well, I think what we want to say, well, ensure the data is between, I mean, so how many characters are in this beginner? So beginner, is that going to be 8 characters? Right, advanced. Yeah, okay, advanced is also 8. Right, then intermediate, well, that's 5, that's 8, that's 11. So, yeah, let's say, right, ensure length, right, is between, or, well, we can say, what, ensure number of characters. Right, ensure number of characters, right, is between 8 and 11. But of course, again, you know, this is not a good validation strategy for this particular example, because I mean, well, when we only know there can be like 3 possible values, then like they could also enter, well, obviously just like kind of AAs, and like this is also going to pass the length check. Yeah, I think that's why, you know, it's kind of sort of stupid really saying this. Right, but anyway, well, let's just say that, right, 8 to 11. Although hopefully, if you did say enums or triggers, I mean, like, assuming the examiner sort of, you know, knows what this is, and well, assuming the examiner, you know, sort of follows actually what they say in the mark scheme, right, which is to sort of accept answers that, you know, go beyond the syllabus, right, but are still correct, then yeah, in theory the examiner should also accept that. Anyway, right now then we want to write a structured query language or SQL script to return the names of all the horses that have the horse level intermediate or beginner. Right, so let's think what data we need. So right, we need the names, and we also need to use what the horse level. And luckily with this, actually, you know, this one's quite simple. Both of these, right, they're both going to be in the horse. So well, both in the horse relation. We don't actually have to do any, you know, inner join or anything. So yeah, let me just zoom out, right, just so I can see it. Okay, right, so let's go select. And right, so we just want the names. So yeah, and right, make sure the capitalization is correct. Right, so this is a big N. Right, select name from. Right, then the table name, right, horse, and again this is going to be all capitals. And well, the reason it's all capitals is because here, right, they've said all capitals. Right, and then we just want to say where. And then right, this is going to be horse level. Alright, I mean yeah, that should be lower really. Right, horse level equals, and that's going to be beginner. Right, and well yeah, or, and well this will be horse level. Right, equals, right, and then intermediate. Yeah, okay, that's fine. I mean, if you had many queries, you can also use in. So yeah, I mean, let me see if I can remember the exact syntax. I think you'd go, so like rather than saying horse level equals beginner, right, you'd say like this. So let's say, right, horse level, and then you go in, right, and well then you just have basically an array of all the things, right. So let's say beginner, right, you know, intermediate, yeah, obviously, right, etc. So like with this example, okay, when we only have 2, of course we can just do, yeah, horse level equals beginner, right, or, but if we had, for example, 5, yeah, having to do sort of, you know, like 4 or statements in that case, right, is going to be quite tedious probably. Anyway, the following SQL script should return the number of riders that have the rider level beginner and have a lesson booked on this date is that 9th of September. Right, so selects, okay, right then there are 4 errors in the script, and identify and correct each error. Right, so the first one, and probably what I'm going to do, I'm probably going to like read through the whole thing, try to identify the 4 errors, right, then I'll write them, okay, once I'm confident I've got them correct. Because otherwise sometimes, you know, you might think that something's an error, but then, you know, when you actually sort of like read the code later, like especially with pseudocode as well, you know, it turns out that like actually this is not an error because, you know, the way the code works. So yeah, that's what I like to try and find all the errors first, okay, then write them. So I'm going to say this one, right, sum, because actually here, well, I mean, here we're just counting the number of riders. Yeah, we're not summing this. And also rider level, I mean, this is a string. So, you know, to sum a string doesn't really make sense. So yeah, I'm going to say, right, this is probably error 1. Right, I mean, as number of riders, I mean, yeah, that seems okay, because well, as this just means we're renaming this column to be number of riders. And when I say renaming, I just mean we're renaming for the output. I don't mean renaming the actual original column, right, you know, on the real data. Right, so from student lesson, yeah, that seems okay. Right then, well, where student ID equals student ID. Now, I mean, this is basically meaningless because, I mean, if we look, I mean, are they both called student ID? So yeah, okay, right, so I'm here, student ID is the primary key, right? This is also, right, identical name, student ID and lesson. So of course, well, here then should be what student.student ID equals lesson.student ID. Right, yeah, or date equals this. Well, I think this one should be and, right, so that's going to be number 3. Yeah, let's see what this is, error 2. Right, and student.rider level equals beginner. Well, I think, well, this is a string, so it should be in quotes. So in here, well, we just want to explain this, right? So let's go sum. Right, sum, yeah, student. Right, student.rider level. Right, let's say should be. And well, let's go count. Yeah, I mean, I think I'm not going to write it again, although of course in the exam you'd want to do that. And of course here, what it's going to be, what student.rider level. Right then 2. So I guess what. Yeah, I mean, I was going to write, you know, we need to specify the table, but I mean, let's just sort of do it like we did before. right, so well, student, right, equals student, right, should be, and that's going to be what I think, right, so yeah, student.student ID. And alright, hang on, right, this is not student, is it? Right, student ID. Okay. Right, so yeah, like this. Right, so student.student ID, right, equals, and that's going to be what, lesson? Okay, yeah, so lesson.student ID. Right, then number 3, well, let's say, yeah, I guess what, yeah, or, right, date. Right, that's a small a. Right, yeah, well, let's say that, right, again, should be, right, let's say and, yeah, date, and I guess we can go what equals, yeah, let's write the whole thing, so, right, 0909, 2023, right, and then number 4, I mean, let's say, I know what, like, beginner should be in quotes. Right, let's say, yeah, i.e., well, of course, right, just beginner. Yeah, okay, right, I think that's fine. Then number 3, a program is written in assembly language. The program is converted into machine code by a 2-pass assembler. Right, draw one or more lines to identify the pass or passes in which each action takes place. Right, so we've got, well, generate object codes. I mean, I could just, you know, sort of say the answers now. But let's just read them, okay? I'll try to explain them. Right, then reads the source code one line at a time, right, removes whitespace, adds labels to the symbol table. Right, so I've just gone here and, well, I've just got an example. And, okay, yeah, that was a bit laggy. Right, okay, so here then, I mean, if we look at this example here, yeah, where is the pen? Okay, here it is. Right, so yeah, if we look at this example here, well, I mean, this is just what from, well, so yeah, from my site, right, asmcode.pro. So I mean, people can check this if they want, right? They can write their assembly. Yeah, they can, for example, well, let's say, you know, look at the register contents, or yeah, step through the fetch to code execute cycle, you know, sort of automatically generate trace tables. But I mean, well, let's think how this works. So let's say here, right, the first one, and of course, like the assembler is going to read through line by line. So it's going to start on line 1, and in fact, let me just zoom in a bit here. Right, maybe not that much. Okay, here we go. So it's going to see this, right? It's going to see what LDD. Now it's going to recognize, okay, this is the opcode, and I mean, of course, it's going to have a list of like all of the opcodes and all of the corresponding binary codes. So perhaps, I don't know, maybe LDD has the binary code. Well, in fact, we can probably see here, to be honest. Okay, so for example, here we're saying what end. Right, I mean, end has the binary code just 0. Maybe like LDM might have the binary code 1, for example. Right, so yeah, each opcode is of course going to have a unique binary value. Right, but okay, so I mean, yeah, well that's going to be fine, right? But then it's going to look at this score, and it's going to see, well, this is a label, right? So a label is basically just sort of a variable, right? Or you can say a label is just a text name for a memory address. And obviously in this case, well, score is represented by, you know, memory address 6, right? Or, you know, line 6, right? Memory address 6. But it's going to think, well, it's not actually going to know what score represents, because I mean it's not seen where score is yet. So if we think, well, it can actually, let's say, I mean, it can't generate the final like machine code or object code. I mean, it also can't like fully. I mean, I guess it can't really replace those, right, with the actual real absolute memory address, because it doesn't actually know like where this score is. Right, that's why, of course, well, then it's going to go to line 2. I mean, line 2 is fine, right? Just increment the accumulator. I mean, it knows everything there. Right, I mean, line 3, again, it's not going to know what this score is. And you can also think, well, let's say if we have some comment, and I think actually maybe comments, they've just to use the slash like that. And obviously, yeah, just some random comment. Now, obviously, I mean, the comments we can just remove on the first pass, right? Since that's some simple operation. It's not going to depend on anything else. So, I mean, all right, let's say removing comments, right, that can be done on the first pass. But then something like this, right, so, I mean, basically what kind of generating the final machine code or the final object code, well, right, therefore that's going to have to be passed too. Because what we're going to do, we're going to get to line 6, and we're going to realize, well, okay, score is obviously on line 6, and we can add this to the symbol table. So what we're going to say, and yeah, this pen is kind of huge to be honest. Right, so score, and we're going to say, right, this is, well, let's say in memory address 6. Right, of course, if we had others, I don't know, maybe like ABC, right, yeah, maybe that's, you know, memory address 10, for example. So that's what we're going to make on the first pass, right? This is the symbol table. Right, then on the second pass, well, now then when we see here, and yeah, maybe I can just erase some of this. Right, so now when we see score, we can actually replace this with the actual memory address, right? Or yeah, with the absolute or, you know, relative memory address. Because what we see, well, yeah, we're going to look in our symbol table, right? Which, I mean, basically it's just a dictionary, right, or a hash map. And of course, where we see 6, right? So what's going to happen? Well, this score is actually going to just be replaced by 6. Because, I mean, well, of course, I mean, like when we're talking about machine code, right? Machine code can't have, you know, some sort of like text name like score, right? I mean, well, obviously all machine code can use is just binary. So of course, what's going to happen is, well, eventually this is going to be translated. Like we said, right? Maybe this LDD is, you know, instruction 1, and of course, well, 6, right? That's just going to be, yeah, 6 like this, right? So obviously, yeah, all of these eventually are just going to be converted into binary. So let's go back and see if we can do this and say, well, generates object code. Well, we said that's going to be the second pass, because again, we need to know like where the actual, I guess we want to say where the actual labels are, or yes, or what memory addresses the labels represent. Right, reads the source code one line at a time. Well, actually, this is going to be both. And if we do look up here, right, it does say, yeah, draw one or more lines. So yeah, this is going to be both. Right, removes whitespace, so things like whitespace comments. I mean, you know, that's just simple operations, right? It doesn't depend on any other sort of data, right, from the first pass. Right, then adds labels to the symbol table. Now, this is actually the first pass as well, because we said, well, this is the one where it's going to say, right, score is, you know, sort of memory address 6. If this was, let's say, maybe, right, using right, symbol table to, I don't know, I guess, to sort of, you know, put the absolute memory addresses. Like if it was actually using the symbol table, right, that's going to be the second pass. But I mean, just kind of like generating the symbol table, right, or making it, yeah, that's going to be the first pass. I mean, hopefully that makes sense. Right then, assembly language statements can use different modes of addressing. Complete the following description of addressing modes. Right, something addressing is when the operand holds the memory address of the data. Right, so I mean, you know, these sort of questions, maybe it's good just to read through all of them first. Right, then something addressing is where the operand holds a memory address that stores the memory address of the data. So yeah, I think this one sounds like indirect. Right, then something addressing is when the operand is the data. So yeah, I think, well, when it is the data, that's just going to be immediate addressing. And we can give an example, right? This is going to be LDM. So let's say, right, LDM 5, you know, literally loading the denary value 5 into the accumulator. Right, this one, so right, when the operand holds a memory address that, yeah, that stores the memory address of the data. I mean, this one, well, if we're using register transfer notation, that's going to be, right, okay, yeah, this, you know, making sure I don't make a mistake. So what we say, yeah, okay, well, let's sort of draw it this way. Right, I mean, okay, they should be square brackets. So here's, I mean, we're kind of saying what the address in the, okay, hang on, right, let's say the contents of the address stored in the MAR are copied to the NDR. Right, and of course, indirect is going to be represented, right, using these double brackets. And I think for an actual assembly instruction, I think it's going to be LDI, right, using Cambridge syntax, or yeah, the Cambridge instruction set. Right, so this is going to be indirect, and then the first one is just going to be direct. Yeah, when the operand holds the memory address of the data. And well, direct, okay, that's just going to be these single brackets. So let's say an example from the fetch decode execute cycle, well, that's going to be what the contents of the PC plus 1, right, and that's going to be what loaded into the, or, you know, copied into the PC. Right, so yeah, just increment in the program counter. And of course, an example of this, well, just LDD, right, so LDD 5 just means what, load the, well, yeah, obviously, yeah, load the contents of address 5, right, whereas, you know, LDI 5, that means what, load the contents, right, of the memory address in, you know, address 5. So like, I don't know, well, let's say, right, if memory address 5 has the value 3, let's say, I don't know, let's say like the value 3, or yeah, sorry, the memory address 3 has the value 8, right, then of course, well, LDI 5 is therefore going to load the value 8 into the accumulator. Yeah, I mean, I think people are probably familiar with that anyway. Right, so this one, data in a computer stored in binary form, state the number of unique binary values that can be represented in 16 bits. Right, so well, the formula for this, I mean, just 2 to the power of n. Now, I remember this something, it's like maybe 65,000, I can't remember exactly, maybe like 65,036, right, something like that. Of course, if we say 8 bits is going to be 256. 24 bits is about, I think, 16.7 million, obviously like roughly. And then if we say 32 bits, well, 32 bits is the number of IP version 4 addresses, which I think is that, like 4.2 billion? Yeah, and of course, well, if we say 24 bits, right, you can think 24-bit color, right, just RGBA, right, and that's going to be about 16.7 million colors. Of course, I mean, you could actually, like, and I think, in the exam, and yeah, don't write 2 to the n, it's going to be 2 to the 16, right, like, in the exam, you would probably want to actually calculate this full value. Now, if you're good at multiplication, like, maybe you have a method of doing this. I think for me, like, I'm probably just going to write down sort of one by one. So if we say 256 is going to be 8, right, therefore if we double that, then what, all right, so I'm just going to write 9, 10, 11, right, 12, yeah, 13, right, 14, right, 15, and 16. Like, probably I won't do the whole thing, because, you can do this yourself, right, so 512, right, 1024, right, 2048, or, yeah, maybe I can, right, if it's quick. Right, I guess 4096, is it, yeah, 8192. Alright, and then honestly, like, here is where I'm struggling, so, I mean, like, if you want, in the exam, you could do that, yeah, although, for me, it's going to take too long, so I'm just going to skip it. But I think it's going to equal this. I would say just use a calculator, right, and then, yeah, in the mark scheme, they do also just accept this. Right, then we want to give the 8-bit 1's complement representation of the denary number minus 120. Right, so 1's complement, well, that's just where we take the positive number and then and then we just invert the bits, right? So of course, any 0 becomes a 1, right? Any 1 becomes a 0. So 120, well, I mean, if we want, we can write out the the positional values, right? 1, 2, 8, 64, right, etc. I mean, I think here, I can just do it. So let's go, right, 0. All right, then of course there will be a 64, right? There will be a 32. Right, that's going to get us to 96. Right, there's also going to be a 16, so that will get us to 112. Yeah, then there will be an 8, right? Then of course there won't be a 4, there won't be a 2, there won't be a 1. And I mean, yeah, this you can check again if you want. Right, so 64, right, plus 32, 96, yeah, plus 16, right, 112, yeah, plus 8. Right, so I think that's 120, right? Then if we just invert them, right, or invert them, of course, it's just going to be like this. Alright, so I mean, yeah, if we see a 0, it becomes a 1, right? If we see a 1, it becomes a 0. And of course, if we wanted to convert this into 2's complement, well, then we would then just, plus 1 to this. And just looking at this quickly, you can see that if we just plus 1 to that, right, it should become this. Because here, I mean, all of these is going to carry. And then, yeah, this should then become a 1. Yeah, and I think, I mean, if we just test that quickly, of course, right, this is minus 128, right, plus 8, so yeah, that's going to be minus 120. And again, right, this is going to be 2's complement. Yeah, this here is going to be 1's complement. Right, then convert the hexadecimal number, right, A04 into denary. Right, show your working. So the working, well, let's say, yeah, okay, right, saying, right, this one is going to be 256, right, this one is going to be 16, and this one is going to be 1. And of course, well, that's just 16 to the power of 0, right, 16 to the power of 1, and 16 to the power of 2. So we've got A256, so that's going to be 10. So our 10 multiplied by 256. Right, I mean, then we've got 016s, right, which is quite easy. Right, then we've got four 1s. So I guess here we'll just, 256, and then, yeah, plus 4. Alright, so yeah, that should be okay. Right, then show the result of a 2-place logical left shift on the binary number. Right, so shifting left, we say these two are get shifting out, and then we're just going to have 2 0 shift in, right, from the right like this. And of course, this is therefore going to be our answer. Yeah, okay. And of course, remember that if we shift, to the left, then we're going to be multiplying by 2 to the n. If we're shifting to the right, we're going to be dividing by 2 to the n. So for example, in this case, well, we're shifting 2 places to the left, right? Therefore, we're going to be multiplying by 4, right? Since of course, well, 2 to the power of 2 is 4. However, of course, right, this only works if we're only shifting out zeros. But in this case, since this started 0, 1, right, then since we lose this 1, right, then the calculation is actually not going to work. So yeah, that's why, this thing, sort of multiplying by, 2 to the n divided by 2 to the n, right, this only works if we're only shifting out zeros. And yeah, I mean, you can say that in the mark scheme, right, when they say, like, what's the effect of shifting left by 3 places? You say, well, it's going to be multiplied by 8, right, if you're shifting out zeros. But yeah, obviously, if you're shifting out ones, right, it's going to be incorrect. Right, anyway, next, so a student has purchased a new laptop. The laptop is designed using the von Neumann model for a computer system. Identify 2 types of signal that the control bus can transfer. Right, I mean, so, well, one, we can just say interrupts. And yeah, another, well, let's say timing signals, right, so clock signals, or yeah, clock pulses. Right, then if we want to get more, I mean, we can also say the read signal, and then I guess also write signal, or yeah, maybe like read write they would consider as being one. So let's just explain how this works, because yeah, I think a lot of people ask, like say what the MAR is actually used for. So okay, I mean, all right, let's say the MAR, right, that has, I don't know, the value 5, or in fact, well, let's go like 5,000, right, we'll make it bigger. Right, let's say the NDR, right, maybe this has the value, I don't know, like 10 or something. Yeah, let's just say 10. Now what we're going to have, right, well, first, I mean, okay, this is going to be inside the CPU, right, so this is going to be the register, and let's say, yeah, this is the CPU here. I mean, I guess, well, yeah, in fact, right, I mean, let's not say registers. I mean, let's say cache, because yeah, the registers we're not really going to be storing things in. Yeah, I mean, not really. I mean, like if you're doing proper assembly, you would, but for Cambridge, right, let's just ignore that. Right, since they only have the accumulator. Right, so let's say it's going to be the cache, right, and of course, we're outside. We're then going to have RAM as well. Let's say that our cache, maybe cache has the addresses like 0 to, I don't know, say 1,000. Of course, in reality, it's going to be bigger than this. But let's say any memory address 0 to 1,000 is going to be in the cache. Right, and let's say what RAM is going to be, I don't know, like 1,001 until, let's say, like, I don't know, like 8 million, right? Just, something bigger. Of course, in reality, right, this is going to be gigabytes, right? So it's going to be billions. So maybe let's say we're at 8 billion, right? If we've got 8 gigabytes. So what's going to happen then is, well, we're then going to have the control bus. And yeah, let's just sort of draw this here. Now, if we send a write signal on the control bus, then what's going to happen is, well, the data in the MAR, right, of course, well, this is going to be sent on the address bus. Now, I suppose, obviously, like, all of this is inside the CPU. Yeah, right. I mean, this is obviously not a good diagram, to be honest. But, we say, obviously, well, the MAR, right, I mean, this data is sent on the address bus, right? The NDR data, well, that's obviously sent on the data bus. So what's going to happen is, well, when all of this arrives at the cache is then going to check, and it's going to see, well, is the address here that's obviously being sent on the address bus, right? Is this address in the cache's range? And we said, well, the cache has the range 0 to 1,000. So of course, since 5,000 is not inside this range, well, right then obviously, well, the cache is just not going to do anything, since well, it's going to realize that this instruction is not for itself. Right, but of course, well, then it's going to carry on the data bus and it's going to reach the RAM. And obviously, well, in this case, right, this is in the RAM's range. So here, well, the RAM is therefore going to have everything it needs, because what we're saying is, well, obviously, right, the 5,000 is going to arrive on the address bus. Right, we're saying what 10 is going to arrive on the data bus, and then on the control bus, we're going to have a write signal, right? And therefore, with these 3 bits of information, well, of course, the RAM can then just write the data 10. Right, at the memory address 5,000. Now, equivalently, I mean, let's say this is empty. Right, equivalently, let's say if we did a read signal, and again, I mean, let's just use 5,000. Well, of course, right, first it's going to go to the cache, right, the cache is going to realize, okay, it's not in its address range. Right, then it's going to pass on to the RAM. Of course, again, right, the RAM is going to realize, well, 5,000 is in its address range. And since there's a read signal on the control bus, then of course, the RAM is going to read the contents of memory address 5,000, right? It's going to put those contents on the address bus, and then of course, right, that is then going to get sent back on the address bus. Not the address bus, right, on the data bus, right? Yeah, the contents from RAM are going to be put on the data bus, and of course, yeah, sent to the NDR. And this is why we think, right, that, well, the MAR, I mean, this is unidirectional, because we think, well, yeah, obviously, okay, let's say addresses have to go to the components, right, the cache and RAM, but, you know, addresses don't need to be sent back. Whereas, of course, well, data, I mean, right, if we're writing data, then, of course, we're sending data out. But, you know, if we're reading data from memory, right, then, of course, we're sending data in. Right, that's why, you know, obviously NDR and also the control bus are going to be bidirectional. Because if we think interrupts, well, of course, interrupts can come from some, you know, sort of external or, yeah, peripheral device. Right, therefore, also interrupts have to be both ways, right? Control signals, yeah, have to be both ways. I mean, that diagram is, well, I'm kind of super messy, to be honest, but hopefully, you know, it makes sense with the explanation. Right then, describe 2 ways the hardware of a laptop can be upgraded to improve the performance, and explain how each upgrade improves the performance. Right, so, I mean, well, let's think what we can say. I mean, one can be what, increased clock speed. Right, well, let's say right, increased clock speed, right, of, yeah, I know, yeah, of the CPUs or of the cores. Let's say, right, since, okay, right, so yeah, since an instruction, right, is executed on each clock pulse, right, yeah, is, okay, executed, right, on each clock pulse. And I mean, like, in reality, right, this is not necessarily true, because, well, some instructions take, you know, multiple clock pulses, right? Things like division, that's going to be a slow instruction, right? It takes, I think, maybe like 100 clock ticks. Yeah, I mean, some are probably faster, like, maybe that's not true. Right, so you execute on each, well, clock tick, or, yeah, clock cycle. Yeah, right, well, let's say therefore, right, therefore, yeah, increasing the amount of, right, or increasing the amount of clock ticks per second, or yeah, clock cycles per second, right, will increase the, well, I guess we'll increase the number of instructions that can be executed per second. Right, yeah, number of instructions, right, that can be executed, right, per second. Right, and then let's say number 2, I mean, I guess what we can mention cache, we can also, say, you know, have more cores. So, like, if we want to write all of them, let's say cache, well, so yeah, obviously, you know, having more cache. And the reason for that is because, well, obviously, cache is going to store what we're going to say the frequently used instructions and data, right? It's also used for something called prefetching. So, sort of loading in instructions before we need them, right? Because, of course, if we load them in before we need them, well, you know, then we're not having to, like, wait to get them from RAM. Okay, they're already loaded in close, yeah, kind of in advance. So, I mean, you could mention that, of course, if we increase the amount of cache, right, we can increase the amount of instructions and data that we're storing there. You know, therefore, it's not having to go to RAM, right, which is going to be slower. Right, and then you can also mention, well, obviously have more cores. And of course, if you say more cores, well, each core can execute an instruction independently. Right, therefore, having more cores mean we can execute more instructions, you know, simultaneously. And of course, you can also say what increase RAM, because what you can have more programs open at the same time, right? You're going to sort of need virtual memory less, and of course, virtual memory is slow because, I mean, well, especially if you're using a hard drive's virtual memory, right? Because you have to wait for, like, the sort of physical movement of the disk. Of course, where you have to sort of load things from virtual memory, right? You know, put them back into virtual memory. And I think, yeah, that thing, what they call it, like thrashing, right, or disk thrashing, when you're basically constantly, like, moving things in and out of virtual memory, the whole system just, you know, comes to a sort of standstill. But I think, I mean, well, let's say cores, well, all right, well, let's not say cores, let's say increase. Right, so let's go increase the number of cores. And let's say, right, since, all right, yeah, since each core, I guess what can, or yeah, will, let's say, right, will execute instructions independently. Right, we'll execute instructions independently. Right, then, I guess what, having multiple cores, Right, having multiple cores, allows us to execute, multiple instructions simultaneously. Okay, all right. Let's say that right. Allows us to, execute, multiple instructions, and probably let's also say parallel, right? So let's say, instructions. Let's say simultaneously, and then in brackets we can put in parallel. Basically these things mean the same, but sometimes they'll say parallel is the keyword, sometimes they'll say simultaneously is the keyword. Although of course, again, like in theory, well, if they say simultaneously, right, in the mark scheme, but you say in parallel, like of course they should give you that. Right, so yeah, it allows us to execute multiple instructions simultaneously in parallel. Hence, hence sort of increasing the total number of instructions per second. Yeah, okay, I think let's say that, right, hence increasing. And again, probably this seems obvious, but often exams do want you to state the obvious. That, like, obviously, if we're executing instructions simultaneously, right, therefore the total number of instructions per second is going to increase. Increasing, the total, right, number of instructions, we can execute. We can execute, let's say per second. Alright, and then sometimes they have a question where, for example, they'll ask, like, why does doubling the cores not double the speed? And I think they say generally that if you add one core, or we can say, let's say like a dual core device will be 50% faster, right, than a single core device. And the reason for that is because, well, basically, the cores have to communicate. And maybe you have, let's say core 1, right, and you might have, well, core 1 is waiting on core 2, right, to finish doing some processing. Because obviously they're sort of using shared data, right? But because one core has to wait for another to finish, right? Because they need communication, keeping everything synchronized, right? That's why you're not going to get like 100% speed up, right? You're only going to get, say, like a 50% speed up. Right then, peripherals are connected to the laptop using ports. A printer is connected to a universal serial bus USB port. Right, describe how data is transmitted through a USB port. So, I think here it's just in the name, right? It's going to be serially, so one bit at a time. Let's say, transmission. Transmission will be serial. Let's say, i.e., like one bit of data. One bit of data, is sent. One after the other. I think that's okay. And then something they sometimes mention is whether it's synchronous or asynchronous. Now, basically, synchronous, well, this means that you can only send, right, when there's an actual signal, or when there's kind of like a pulse signal, or like a sending signal. And also, with synchronous, well, the receiver has to acknowledge. So it's kind of like analogous to TCP, where when they send the data, well, okay, the receiver is going to receive it, but then the receiver then has to sort of send a corresponding signal back, right? Just acknowledging that it's successfully received the data. So of course, well, the advantage of synchronous is going to be reliable, right? But it's going to be a little bit slow. And then if we think, well, let's say like UDP. Now UDP, right? They call asynchronous. I think I don't really have space to write this, right? Asynchronous. So asynchronous, again, that's literally just, send all the data, and like hopefully the receiver, gets all the data, right? Hopefully the data is, not corrupted, but again, it is going to be less reliable, right? It's just more about speed. So we can also say that, right? Data transfer, right, can be either synchronous, right, or asynchronous. Asynchronous. Right, then a monitor is connected to the laptop using a different type of port. Identify one other type of port that can be used to connect the monitor. So I think the obvious one was HDMI, which I think was like high definition, I think multimedia interface. And yeah, I think this is multimedia. And of course, when we say multimedia, well, that means, video and audio. I think another one you could probably say is VGA, which I'm not sure what this means. Maybe video graphics adapter, like maybe something like that, or yeah, maybe something completely different. And yeah, I think now there's also another one. Is there one called like DVI? Yeah, I think maybe there's something like that. But honestly, I'm just go for HDMI, right? It's the most common one. Right, the laptop has system software. Describe how the operating system manages processes in the computer. Okay, so we can say what okay, well let's try and do a plan. So let's say what load to RAM. Right, so yeah, each process is going to be loaded into RAM. Let's say maybe allocated memory, and of course you shouldn't have two processes that access the same memory. Let's also talk about scheduling, and I'm going to say maybe I don't know, like round robin, right? So round robin scheduling, and what this means is that each process will execute for a specific time slice, right? Maybe like I don't know 100 milliseconds, and then after 100 milliseconds, right, then there's going to be an interrupt. And then yeah, another process is going to come in, right, to get another 100 milliseconds of execution. And the advantage of this is, well, let's say we have some process like I don't know, maybe video editing, right, video rendering, and maybe it takes 24 hours, right, just to render some video. Now you wouldn't want it where you have this video using 100% CPU, and then the whole computer just freezes because, well, like I know, obviously, like yeah, anytime they try to like open another program, right, it's just not going to open because again the video rendering is using 100% CPU, right? That's why you're going to have, right, each program executes for 100 milliseconds, right? Therefore every program or every process, right, is going to get its own time slice. Yeah, no, I think that's probably enough, right? So we're saying yeah, loaded to RAM, we're allocating memory, right? We're doing some round robin scheduling. Yeah, I think that's probably okay. So let's say, yeah, maybe each process, right, let's say will be loaded from secondary storage, right, yeah, from, right, secondary storage, right, into RAM. Right, let's say, yeah, where it's given a unique or yeah, I guess, right, where it's allocated. Yeah, I think actually, right, no apostrophe there. Right, yeah, where it's allocated. Right, let's say, yeah, its own unique memory space. And I think let's just explain this in brackets, right? Let's say to ensure, right, two processes aren't overwriting. And obviously, this can be accidental, right, or it can be malicious. Yeah, okay, let's say to maybe improve security and kind of, basically, like lack of, well, I guess not lack of crashing. I guess you say reliability. Yeah, all right, let's say, all right, to, yeah, I maybe improve, right, improve security, right, and reliability. Right, yeah, by ensuring. Right, let's say I don't know, yeah, two processes aren't overwriting each other's memory addresses. Right, two processes, yeah, let's say, right, aren't, right, yeah, writing data. Also reading data, you wouldn't want one process reading another process's, data. Like especially, of course, if that process, I don't know, maybe it's some like, I don't know, some like banking software or something. And of course, yeah, the user has actually, put their banking details right into this software. Right, yeah, two processes aren't, well, so yeah, I guess we're accessing, because again, that's going to include reading and writing. Right, so accessing data, right, let's say, in the other process's address space. Yeah, is it like that, or the other process's address space? Right, I guess let's talk about scheduling. Right, yeah, also, let's say maybe a scheduling algorithm will be used. Right, okay, yes, scheduling algorithm will be used. Right, let's say, yeah, e.g., round robin or like priority round robin. Well, let's say round robin. Yeah, which I guess maybe which allocates. Right, which allocates a time slice. Right, okay, time slice, yeah, for each process. Right, let's say, yeah, ensuring that one process, doesn't use up all of the CPU. Or I guess, well, let's say, right, ensuring fair access, right, to the CPU, right, for all processes. And I mean, like, probably, yeah, maybe we can talk about interrupts. So, yeah, if an interrupt occurs, then okay, right. So if an interrupt occurs, we can say what a specific process can be, switched out, right? So it's going to be a context switch, and then what either the ISR is going to be switched in, right? Yeah, or another process is going to be switched in. So yeah, let's say that, right? Interrupts. Yeah, I guess, right. Don't know. Will also be handled or implemented. Right. Let's say, yeah, to allow maybe a higher priority process. Right, let's say a higher priority process, right, or ISR. Yeah, right, or right, ISR, and let's put in brackets what interrupt service routine. And I mean, this is kind of saying, the same as what we said, like with the round robin scheduling, to be honest. Yeah, no, okay, so I was just checking, like, did I say time slice, right? So I did say that. And again, time slice, like, 10 milliseconds or 100 milliseconds. Right, interrupt service routine. Yeah, to have access to the CPU. Yeah, I think that's enough. 5 marks, right? That's quite a difficult question. And I mean, okay, well, just to sort of explain what round robin is, because I mean, really, this is more A2. Let's say we have like 4 processes, right? Let's say you got A, B, right, C, and D. Now, right, each one is going to execute for, let's say, well, say I don't know, say like 10 milliseconds, right? If we choose 10, yeah, or I don't know, I mean, let's say 100, or I think 100 is fine. Right, so of course, right, so A is going to execute for 100 milliseconds, right? Then, of course, then it's going to go to B. Right, of course, B is then going to execute for 100 milliseconds, right? Then it's going to go to C. Right, of course, C for 100 milliseconds, right? Then D, right? Then A. Of course, yeah, just round and round, right? Eventually, let's say, for example, if B finishes, well, then of course it can go from A to C. Yeah, no, of course, maybe then we have some other process, right? E comes in, and then of course it's going to go A to E, right? Then to C. Yeah, I think people should hopefully understand what that's doing. Of course, the benefit again is that, well, I mean, you're not going to have something called starvation, and starvation is just, well, where the CPU is using like 100% of its resource, right, on one particular process, and yeah, nothing else can actually ever finish, right? Because, well, yeah, nothing else can ever actually get access to the CPU. Right, then this one we want to describe the purpose of utility software in a computer. So I say what this is about, maybe the maintenance, right? If we're talking about like defragmenters, I guess what sort of maintenance, performance, and also sort of the health, right? If you're talking about antivirus, yeah, I mean, let's say maybe to ensure the smooth running. Yeah, let's say, I mean, I like maybe that's not the most technical, right? The smooth running, right, of the computer. Yeah, let's give an example, right? So say, yeah, so again, I want to say like maintenance. Yeah, okay, well, let's say, right, sort of ensuring like good performance and like health. Yeah, I think that's okay, right? Ensuring, right, good, I don't know, yeah, like overall, right, performance and health of the system. Yeah, I think I probably could have combined that into fewer words. Right, and then I think here let's give an example. So right, let's say e.g. right, yeah, disk defragmenter. and I mean probably, well, let's try and list, you know, as many as we can. Right, so obviously disk defragmenter, and that's going to be about the performance. Right, if we talk about the health, well, I mean, let's see what antivirus or anti-malware. Right, we can also say what disk checker. So disk checker, I mean, that's going to check, well, yeah, I mean, is any of the disk, right, corrupted? I mean, you can probably also mention disk formatter. Now, again, I mean, this is really going to be, well, I mean, either when you first, you know, sort of get the computer, right, where you format the disk, right, for the first time. Yeah, or again, if there's been some problem, right, maybe you want to just, you know, wipe all the contents, right, just reformat the disk. Yeah, or maybe you want to sort of, you know, use a different file system instead. Because, I don't know, like maybe you're using, for example, like, say, like FAT32, which, like, I'm not entirely sure, but, you know, I think, well, this is going to be slower. Right, you're also limited in terms of like the max file size, right? And of course, yeah, maybe you'd want to upgrade that to, is it, yeah, I think NTFS. Yeah, so the NT file system, right? Windows NT file system. You know, or of course there's, yeah, like Linux file systems, right? You know, various others. And yeah, let's just say etc. Yeah, I mean, you could also mention compression software, although, I mean, compression software, of course, well, that's going to, you know, reduce the reduce the size, right, reduce the amount of storage. But in terms of performance, you know, that's actually probably going to slow the computer, since, of course, you know, when you actually want to access files, well, before you actually access it, you know, you first have to decompress it. So yeah, I think compression is actually going to make it a bit slower, right, in terms of kind of accessing files. Right, then draw the logic circuit for this logic expression, right? So right, R, X, or S, and right, not T nor P. Okay, so here, I mean, well, let's just start on this one first then. So, right, XOR. So XOR, of course, well, that's just the line. And then, yeah, my drawings are quite bad, to be honest. Right, I'm just going to label this. Right, let's go XOR. Right, the next one, well, let's go not T. Alright, okay, not T. Right, then nor P. Okay, so... Right, and let's go here then. So nor, well, right, that's going to be the or like this. Right, then just, you know, with the not in front. So yeah, let's label this, right, that's not. This one is nor. And then, right, we just AND them together at the end. Alright, so I think, I mean, actually, yeah, these two logic expressions have been quite simple. I think maybe it was the previous A-level series. And when I say previous, I mean like actually, well, the sort of previous ones that I did, which was actually I think October, November. Yeah, no, I think I don't know. It's one of the 2024 series. Yeah, even that, or possibly even one of the IGs. You know, they've actually been a lot harder. But yeah, I mean, you know, this one is relatively simple. Right, then complete the truth table for this logic expression. So again, I think here we can just work, you know, left to right because we don't have any, you know, sort of funky brackets. Right, so not P. Yeah, and I guess what I'm just going to write not like this. I mean, you know, you could of course just write, for example, not P like that as well. Right, but let's go not P. So here then, well, that's going to be 4 1s and then, yeah, 4 0s. Right, then if we go not P or Q. So, yeah, I guess, I mean, let's write the whole thing. Right, so here we want to think, well, or, right, of course, well, I mean, these first 4 are definitely going to be true because, well, not P is true. Right, then we can just look for or Q. And, well, or Q, right, this one and this one. So, yeah, these two are going to be 1s, right, and then, yeah, these are going to be 0s. Right, then if we go, well, R nor Q. So, let's think about nor. Now, if we have or, well, or is going to be, what, 0, 1, 1, 1. Right, therefore, nor is going to be, yeah, 1, right, and then 3 zeros. So, right, R nor Q, that's going to be what, this one and this one. And we're looking for where they're both 0. And I guess what, that's only going to be this one and this one. Right, so yeah, that's R nor Q, and then let's just fill in the rest with zeros. Right, then we just XOR. So XOR, we're looking for where they're different. Okay, where they're different is going to be a 1. Right, where they're the same is going to be a 0. So I'm just going to start on this one. Right, so of course here they're different. Right, yeah, here they're different, here they're different, all right, here they're different, all right, here they're different, and here they're different. So for me, I mean, what I like to do is, well, I like to look for the 1s, right, and then of course right here, just fill in these with zeros. Right, so hopefully that's correct, you know, again, as long as there's not any sort of silly mistakes. Okay, right then, a software developer is working in a team writing a program for a client. The developer is writing a new program library to be used by the other team members. Define the term program library. So what we can say, kind of like pre-existing code written by another programmer, to perform specific tasks or specific functions. Right, modules. So right, let's say pre-existing code. And I think let's put here, let's say modules. Written by another programmer. Or programmers, right? Yeah, can obviously be plural. Well, let's say rather than another, right? Let's say other. Right, let's say program. Yeah, I'm going to say like programmers, right, with an S in bracket. Right, to perform specific. To perform specific functions, I guess. Honestly, that's kind of the definition. Like, is this enough for 2 marks? So maybe we can mention what the programmer can then import. So this is us, right? So I guess we can say we. Here they say the developer. Let's say the developer. Let's say maybe the developer in question, right? Just to specify like it's the one in the question, right? Not not the developers that have actually made the libraries, right? Let's say can then import these libraries right into their own projects. Import these libraries into their own project. To use this code. Or we can say to use these functions. I think that should be okay. Right, and then how many more is there? Okay, right, just not too much. Right, explain 2 benefits to the developer of choosing to create a dynamic link library. Right, so this one again, I do also have a picture here. Let's zoom out here as well, because I think a lot of people get confused about this, right? It's quite complex. So actually, maybe first let's just sort of draw a picture of what it is. Now, if we say static, now let's say you're going to have your executable, right? So this is our exe. I guess on a Mac it would be something else. Obviously Linux as well is going to have a different extension. Now of course the exe is going to have data. It's going to have our instructions. If we just simplify that, let's call that P, right? So this is our program, and then like part of this is also going to be the libraries. So what you're going to have then is you're going to have I guess the the whole exe. Well, not only is there going to be our code, but there's also going to be the library code. It's all just going to be combined into one file. So obviously that's quite simple, right? When you're distributing, you're literally distributing one file. Right, if we're using dynamic, DLLs, right, dynamic link libraries. Well, here this is where we have our program. Let's say here we have maybe library 1, let's say library 2, right, and library 3. Well, here our program is just going to have references to these. So for example, maybe this is a name, right? Maybe you have like win, and I'm not sure the exact name. Let's say like win32, right, .dll, right, some Windows, right, DLL. So it's going to say, well, our program needs this, right? Then the operating system will then look, right, and of course, it's going to try to find this on its system. We're just going to have a reference to this. Now the benefit of this, well, as we can see, right, let's just go down here. So the benefit of dynamic linking, well, it's going to be a lower file size because we're not actually including the libraries inside our final executable, right? Because it's lower file size, right, therefore less memory is required in RAM. Also, this can be, let's say, often, like especially for sort of common system libraries, things like input output, maybe some networking library, things like this. Like probably many programs, even most programs are going to be using these same libraries, right? Therefore, it doesn't really make sense to have static linking, where if you have 10 programs open, right, you've got 10 copies of the same library, right, all in memory. Instead, what you can have is, well, let's say, right, this is our program 1, right? This is our software, but let's say we have another thing. This is like say some like web browser, and maybe this web browser also needs library 1 and let's say library 3, for example. Well, in this case, of course, right, we only need one copy of these in RAM, and yeah, both of these, right, both the web browser and our program, right, can both reference the same, the same dynamic library, or the dynamic link library. Right. Also, well, therefore, it's going to be easy to cache because we only need to cache one library. And obviously that library can be used by multiple processors. And when we say cache, we're talking about what the processor cache. So the operating system can hopefully cache it well. Right, if the library updates, the program will automatically use the new version. Right, so let's say if there's a bug, or if there's some security vulnerability, right, performance update, right, then we only have to update it one time. We only have to update one copy of the library. So let's say, right, this L1 here, right, we just update this, and then, right, automatically, the web browser and our program, right, they're going to automatically be using this new updated version. Whereas, of course, if we think static, if we're shipping the library as part of the exe, right, that's when the user will then have to download the entire exe again. Right then, I guess if a manual update is required, then only one instance has to be updated. So like if, let's say, the user has to manually download the DLL, right, of course they only need to install one DLL on their system. Whereas let's say if you're using static, well, they'd have to manually update every single program, right, that uses that DLL. Right, that uses that library, right, if we're talking about static. So right, let's try and write this then. We can say it's going to use the program size will be smaller. Right, okay, program size, will be smaller. And we can also say, right, hence RAM usage is also lower. And I mean, when it says two benefits, I think we can really combine those into one. Right, since the DLL, or since the library, let's say, right, is simply referenced. Right, let's say, simply referenced by the program. Right, rather than being included. Right, let's say, right, rather than being included. Right, included, in the, I guess, executable. I guess executable file, I think that's okay. Right, then two, I guess we can say, I'm trying to think about the best one. I mean, maybe, like, if there's a bug, we only have to update it one time, it's going to automatically update. Let's say that. So, maybe the, let's say if, right, let's say if an update is required. Or or let's say, right, if the DLL is updated, and then, right, let's put in brackets, right, e.g., right, due to, right, security vulnerability. Right, let's go, maybe performance improvement, or you can say optimization, right? Let's say performance optimization. Right, let's say or new features. And of course, if we think about maintenance, right? So security vulnerability, that's going to be corrective maintenance, right? We're fixing something that's broken. Right, performance optimization, right? That's going to be perfective maintenance. Then new features, or changing features, right? That's going to be adaptive maintenance. And I suppose really, I mean that's a P2 topic, right? Paper 2 topic. Right, so if the DLL is updated, right, we can say the I guess the programs that link to it, or the programs that reference it, right, or link to it. Right, the programs that link to it, right, will automatically, automatically use, right, the new, updated library, or the new updated version, right, version of the library. So I think that's okay. Right, then the development team needs to use a translator whilst writing the program for the client. identify whether an interpreter or a compiler would be more appropriate at this stage of the program development. Right, so when they're talking about writing, and I mean, like here when it says justify, well, we can choose. Like usually, you know, of course for distribution we want to use a compiler because, well, one, it's going to be faster, you know, it's just going to execute more quickly. Right, two, of course, we only need to ship the actual executable, right? Whereas if it's interpreted, well, we also need to ship the, well, yeah, obviously the interpreter, right? Like Python or, you know, Java, for example. But yeah, I mean, during development, they often say, right, yeah, I mean, not debugger, right? They say what, interpreter. Yeah, and let's say, well, since basically it's going to make testing more easily. Yeah, all right, let's say, yeah, this makes testing more easily. Right, this makes, yeah, testing more easy. Or yeah, I guess, well, just easier, right, not really more easy. Right, this makes testing easier, right, since if a bug is developed, or, well, right, yeah, if a bug is discovered. Yeah, I think my brain is kind of stopping. Yeah, not really working properly. Right, since if a bug, right, is discovered, then we can say, well, obviously, yeah, the program will crash at that line, but I guess we can say what we can, you know, directly fix that line and resume execution of the program. Yeah, okay, let's say, right, right, yeah, maybe we can, let's say, fix, yeah, the, I guess what, the erroneous code. Yeah, and let's say resume execution. Right, from, yeah, I don't know, like, you know, from that point or from a previous point. Or let's say, yeah, from that point. Right, to verify if our changes worked. Yeah, let's say, right, without having to recompile. Right, without having to recompile the yeah, the entire code. Let's put in brackets, right, which is slow. Yeah, I mean, are there any other advantages? Yeah, I mean, I think for that, you know, that's probably all I could say. Like, if I had more time in the examiner, I'd probably think, you know, see if I could think of something else. Now, if we're saying compiler, now I'd say for a compiler, well, one thing is going to, for example, it's going to check all the syntax first, right? Therefore, it's going to notify you, right, if there's any syntax errors. It can also do more advanced things like, for example, it can detect, right, if there's any type errors, if, you know, you've got, say, like a wrong number of parameters, right, if there's any. Yeah, I don't know, if you have some, okay, let's say you've defined a function, right, but you're not returning a value from it. Yeah, like a lot of, let's say a lot of IDEs, right, they can actually do a lot of this, you know, kind of like, well, static analysis of code. Yeah, but I think, right, yeah, I think that's probably okay. I mean, yeah, maybe for 3 marks. Right, then the development team uses an integrated development environment IDE. Complete the table by describing the typical features found in an IDE. Right, so I'm just going to load this up quickly. Let's just go IntelliJ. And yeah, this should load, right, pretty quickly. Right, so the first one it mentioned, I think, was what, breakpoints. So this is an example I've demonstrated a few times, but if we just run this in debug mode, and as you can see, right, this is just bubble sort. Then a breakpoint, well, the let's say execution is going to pause, right, on this red breakpoint. And yeah, just wait for it to compile. Right, so here then we can see it's paused here, and well, we can see the actual contents. So here it's saying, well, right, this is the contents of the array. Okay, the times to the loop is 8, right, did swap is true. Of course, we can also see this right down here in the report window. Right, then we can do what's called single stepping. So, okay, yeah, here we go. And you see right now it's told us if we can see in yellow. I guess yellow, right, this is going to be what's changed. So saying, obviously, right, yeah, these yellow values have changed. So, right, I mean, this is single stepping where, well, I suppose, right, this is actually not really single stepping. Single stepping, is it maybe this one? Okay, right, so this one is single stepping where we're just executing, right, statement by statement. And of course, yeah, we can like directly see what's changing. Right, and then, yeah, is there anything else? Right, so we said, yeah, breakpoint, single stepping, right, dynamic syntax checks. Well, of course, I mean, that's just going to be checking the syntax as you're typing it. So let's just pause this. Like, let's imagine, I don't know, we go, for example, S out, and right, let's imagine we have something like this. Well, I mean, now, right, since we don't have the closing quote, right, it's just going to tell us here. Yeah, okay, so it's going to give us that error message. Right, then context-sensitive prompts. Well, this is going to be the one where, I mean, basically just the code suggestions. Like, if we do system, right, and then it's going to say, right, well, these are all the, let's say, properties or methods that we can use. Right, then, of course, we can go out, right, and then print. And again, right, so yeah, just going to give us, right, all of the methods. So, right, let's just explain this. So, breakpoints. And, yeah, let me just go full screen. No. Right, okay, so I guess for breakpoints we can just say what to define a pause point during debugging. Yeah, or let's say let's say program execution. Right, we'll pause at this point. Right, let's say like to allow. So to allow the developer. Yeah, to allow the I guess what development team, or yeah, developers. Right, let's say to, right, e.g. Right, inspect. Yeah, inspect contents of variables. Right, in report window. Yeah, I mean, so hopefully that makes sense. Right, yeah, I mean, or we can say, I don't know, yeah, like, or single step. Right, of course, yeah, single step, like, to the next process. Oh, yeah, or single step to the next, I guess, what, the next statement. Right, dynamic syntax checks, so I guess, I mean, what, checking the syntax, or yeah, ensuring the syntax is valid. Right, ensuring syntax is valid. Right, let's say, yeah, as user is typing. And let's say, right, notifying them. And I mean, well, let's say how it does that. So, right, e.g. red underline. Right, e.g. yeah, red underline. Right, let's say, yeah, and providing error message. Right, if problems, or yeah, if syntax errors. Right, if syntax errors, yeah, obviously what you say, right, exist in code. Right, context-sensitive prompts, so this is going to be, I guess what you'd say, like, relevant code suggestions based on what they've typed. Yeah, let's say, right, providing. Right, let's say relevant, right, code suggestions. Right, I mean, if we're talking about, again, this is kind of A2, right, like object-oriented programming, but you could mention, for example, well, like we saw, right, you know, when we do the dot, right, then it's going to give us a list of, like, yeah, all of the, well, methods, right, so methods, you know, just functions, procedures, and yeah, attributes, well, I mean, we say attributes, right, basically just variables, right, so providing relevant code suggestions, yeah, I guess, well, as the user is typing. And again, you know, I think for this, well, let's give an example. Right, so yeah, e.g., I don't know, like modules. Yeah, I mean, you can say, well, modules, right, slash methods. I don't know, yeah, like variables. Right, yeah, etc. Right, then single stepping. This is what just kind of executing statement by statement. Right, let's say you're executing, right, statement by statement. Right, and pausing execution between each. Right, pausing execution, yeah, between each. And again, right, to allow developers. I mean, what, you know, to see the contents of the variables. Or yeah, you know, see contents of report window. Yeah, let's say, right, you know, I don't know, like find specific cause of error. Alright, and is there, yeah, okay, right, so the last question, and I think this video has been super long, right, let's try and finish quickly. Right, one section of the program is being developed will convert user speech into commands. explain how artificial intelligence AI can be used in this program. Right, so I think what we can say speech recognition, maybe I guess what speech recognition model, right, obviously using machine learning, where you're going to have, let's say, lots of speech is loaded into this, and then, well, based on this, and you can say, right, either it's going to be supervised or unsupervised. And of course, I mean, I guess in this case, like, it would probably have to be supervised, to be honest, where you'd have, well, this is the audio, right, and then you'd have, this is the corresponding text of the audio, and then of course, you just, load in millions of files like that. Then of course, the what the machine learning model can then recognize, well, if we have, right, this particular, sort of, set of frequencies, right, then it corresponds to this particular word. So yeah, let's say that maybe, maybe a machine learning model, or a machine learning, right, speech recognition model, right, could be trained. Right, let's say using large amounts. Right, large amounts. Right, let's say of, and we'll go. Let's say, what is it, like, transcribed? So I think if we say transcribed, I mean this means it kind of includes the subtitles. Right, transcribed. Audio files. And I guess. Well, I guess we can say and learn, right, and learn to detect, let's say, what the frequency signatures of individual words. Let's say frequency signatures, right, of individual words. Right, let's say, so I mean now let's kind of relate it to this particular program, right, using commands. So we can say when the developer, or when the user, right, when the user speaks, into the microphone, or into the, I guess let's say into the microphone. Right, we can say, I guess what the AI model, right, let's say, the AI model, I guess maybe will, and of course, this can also be like a neural network, you can call it that if you want. Right, will, I guess try to find the sort of, corresponding command. Or let's say, right, try to find the corresponding command. Right, command. I guess, if one is found. Because obviously, maybe they type it, or well, maybe they say something that's, not a valid command. Right, and let's say, and execute that part of code. Let's say that. Right, let's say, execute the code, right, for that command. Alright, anyway, guys, I mean, I think that was a super long video, possibly the longest out of, these, out of these paper ones. But, as always, like, hopefully this was useful, and any questions, well, just ask in the comments. And, see you again in the next video.